Millions saw the apple fall, but only Newton asked why. This quote from Bernard Baruch is important not only for understanding the importance of theories we derive in science by asking why and how, but also for appreciating Newton's extraordinary genius. If you acted as if everything were known, there would be no need to explain even a simple apple falling. But if you want to understand nature, even a falling apple must be questioned. Newton did exactly that. Today, we'll delve into the inner world of this genius and examine his personality. Newton was born on Christmas Eve, December 25th, in the year 1642. As you know, the Gregorian calendar was adopted instead of the Julian calendar in 1582 to address the discrepancy between calendars and astronomical events. England, where Newton was born, had not yet adopted the new calendar, like the rest of Europe. Therefore, according to the new calendar still in use today, Newton was not actually born on December 25th, but on January 4th, 1643. This uncertainty also casts doubt on the claim that Newton was born on the day of Galileo's death, because Galileo died on January 8th, 1642, according to the new calendar, 361 days before Newton was born. Despite this, Newton would remain remembered throughout his life as a chosen figure, even if for such flawed reasons. Newton had a troubled childhood. Born prematurely, he was tiny. He was named after his father, Isaac Newton, a wealthy farmer who died 3 months before his birth. According to legend, when God announced the promise of a child, Abraham, then very old, and Sarah, who had never had a child before, laughed at the news. Therefore, God decreed that the child's name should be Isaac, a word meaning "he who will laugh." However, Newton would not laugh much throughout his life. When he was only 3 years old, his mother, Hannah Ayscough, married Barnabas Smith, a wealthy clergyman, leaving Isaac in the care of his grandmother. This abandonment led him to hate his family, especially his stepfather. Years later, in a letter listing the sins he had committed up until the age of 19, he would mention threatening to burn his mother and stepfather while they were still inside the house. From 12 to 14, Newton lived in the home of William Clark, an apothecary. There, he developed an interest in both chemistry and its pseudonymous ancestor, alchemy. He also attended King's School in Grantham to learn Latin. His signature on a windowsill there can still be seen today. His stepfather died around this time, and his mother, citing poor grades, wanted to withdraw him from school and encourage him to pursue farming. Fortunately, the headmaster, Henry Stokes, resisted Newton's interest in science and ensured his return to school. Determined to put a boy who was bullying him in his place, Newton quickly improved his grades and increased his popularity with the sundials and earth mills he designed. This pattern would continue throughout Newton's life. He would not stop until he had crushed anyone who challenged him. Thus, by the time he finished school in 1661, at the age of 18, his grades were excellent, earning him acceptance into Trinity College, part of the University of Cambridge. At the suggestion of his teachers, Newton did not limit himself to the teachings of Aristotle, as his university classmates did. He also studied contemporary physicists, mathematicians, and philosophers such as Descartes, Copernicus, Galileo, and Kepler. One day, he bought an astrology book at a science fair. At that time, astronomy was just beginning to develop, and the study of celestial motion was dominated by astrology, now a completely pseudoscience. However, Newton, lacking sufficient geometry, couldn't understand the motions of the stars. Therefore, he read Euclid's legendary Elements, but didn't particularly enjoy it. Descartes' geometry book piqued his interest. However, this period, during which his appreciation of his predecessors hadn't fully developed, struck a blow to his face when he sought a professorship at Trinity College in 1664. Isaac Barrow, the doctor who examined him, was astonished by Newton's shortcomings in geometry. This spurred Newton on even more, and he reread the Elements, realizing he had wronged Euclid. Years later, in a letter to his bitter enemy, Robert Hooke, he quoted a quote from Bernard of Chartres, describing scientists like himself as dwarfs perched on the shoulders of giants who preceded them. This quote later became popular as, "If I have seen farther, it is because I have stood on the shoulders of those who came before me." As time went by, Newton became interested in optics, the science of light. He spent his days contemplating light, conducting experiments, and examining their consequences. But at this point, a ruthless enemy arrived. This enemy was none other than the Black Death, which ravaged London. Following the outbreak, Trinity College was closed, and Newton returned to his home in Woolsthorpe. In that garden, there was also an apple tree, and that tree would change Newton's destiny. First of all, I want you to know this. No reliable source states that an apple fell on Newton's head. However, Newton did indeed mention this incident in his own lectures. For example, his niece, Catherine Barton, and the famous writer Voltaire told this story, and it was popularized by them. In other words, the apple's fall truly inspired Newton's reflections. Why did the apple fall straight toward the center of the earth instead of flying off to the right, left, or into the air? According to Newton, this was because gravitational force existed in nature. This force was not on or near objects, but precisely at their center. Therefore, it must be related to the object's mass. According to Newton, this force wasn't infinite. It decreased with distance from Earth. Newton had thought about this centuries before, but it would take him a full 20 years to develop it into a developed theory. Newton also believed that this gravitational force wasn't limited to Earth and an apple. All objects in the sky should possess this force, and thus he could explain the motions of astronomical bodies. But there was a small problem. The mathematics developed up to that point wasn't sufficient to explain these motions, and Newton realized this and invented calculus. After achieving all this, he reached the age of 26. His work between 1664 and 1667 would be remembered as his Annus Mirabilis, or the miracle years. This term would be used again 240 years later, in honor of Albert Einstein, who definitively demonstrated the incompleteness of Newton's theory, succeeded in developing a better one, and revolutionized our understanding of space, time, mass, and energy, publishing 4 papers in a single year. Meanwhile, Newton began pushing the boundaries of his experimentalism. He refused to accept anything that wasn't based on experience. For example, he distrusted optics textbooks when studying light. He once attempted to alter the shape of his eye by inserting a blunt needle under his eye to understand how our eyes perceive color. He also attempted a particularly dangerous experiment, covering one eye with his hand and staring at the sun for extended periods. This caused some damage to his retina and altered his color perception, but all this frantic work would lead him to unlock the secrets of optics. Most importantly, using his optical knowledge, he invented history's first reflecting telescope, now known as the Newtonian telescope. This telescope was 10 times smaller than the telescopes of the time, yet still more powerful. All these achievements culminated in his appointment to the Lucasian professorship at Cambridge University in 1669. However, the darkness within him was rapidly encroaching on his character. Newton was a cranky and eccentric man. On the one hand, he was excellent at social interaction, but on the other, he was also very fragile. For example, in 1671, he published a paper claiming that white light was a mixture of other colors, and that colors were created by the refraction of white light. Today, we know this to be absolutely true. At the time, it was believed that colors appeared as a mixture of light and darkness. This unconventional work was initially welcomed by many, but in his paper, Newton failed to properly explain his experiment with prisms. When other physicists replicated his method, they failed to reach the same conclusion. This led to growing opposition to Newton's color theory, and ultimately, Robert Hooke harshly criticized Newton and his methods. This criticism was the catalyst that would drive Newton, who could not stand criticism and always believed he was right, into obscurity. It was also the reason Newton hesitated for years to publish his ideas on gravity, even if they were erroneous, due to the scientific community's constant criticism. This is where Newton's mysterious and unknown nature manifested itself. First of all, Newton was born into an Anglican family and was an incredibly religious man. But his perception of Christianity was not part of the mainstream of the period. It was quite incompatible with Orthodox Christianity. For example, Newton rejected the Father, Son, and Holy Trinity, which are at the heart of Anglican Christianity. Newton was obsessively obsessed with unraveling the mysteries of the Bible. He believed that if he applied his experimental methods in physics to the Bible, all the secrets of God would be revealed. Therefore, he spent his days reading different translations of the Bible and identifying inconsistencies between these translations. That's why he focused on the Book of Revelation, which contains the most metaphorical expressions of the Bible. According to Newton, the devil descended to earth in the 3rd century and made people believe in the lie of the Trinity. In short, according to Newton, it was called the Trinity. There was nothing wrong, but whatever the reason, this belief was an unacceptable perversion for the England of the period. Think about it. Newton was the head of Trinity College at that time as a Lucasian professor. This is why he had his religious beliefs. He always had to hide it. Newton was also interested in the pseudoscience of numerology. He attempted to predict the timing of the apocalypse, particularly by using numbers and narratives in the Bible. He considered many possible years for the apocalypse, and the year 2060 particularly caught his attention. According to Newton, on this date, Jesus would return, reign over a global kingdom of peace, the corrupt Trinitarian Church, which he viewed as Babylon, would collapse, and the true word of God would begin to be freely spoken. Furthermore, Newton believed that the Jews would return to Israel at that time and rebuild their temple, and that an apocalyptic war would begin due to Israeli occupation efforts. Newton didn't just believe in these superficial beliefs, nor in a much more complex understanding of religion that I can't fit into here. He provided detailed explanations. For example, Newton left behind approximately 2,000 books after his death, approximately 27% of which were theological books. Mathematics and astronomy accounted for only 8.3%. Physics comprised only 3%. Another thing he had been interested in since a young age was alchemy. Alchemy also influenced Newton's worldview. The foundation of alchemy was the ability to transmute less valuable elements like silver or iron into more valuable elements like gold. Indeed, alchemy was banned in England in the 16th century for fear that if everyone produced gold, the king's power would be taken away. For this reason, Newton kept his alchemical work highly secret. In fact, of the 10 million words of texts written by Newton that have survived to this day, approximately 1 million are about alchemy, far more than his works on physics or mathematics. This demonstrates Newton's profound interest in alchemy. For example, he was obsessed with the Philosopher's Stone, popularized today by Harry Potter. Legend has it that this stone was used in the creation of the universe and still ensures its orderly functioning. Furthermore, the ability to transmute all elements into one another lay at its core. In fact, today we know that one element can transform into another, but this transformation does not occur through magic or sorcery like the Philosopher's Stone, but through nuclear reactions known as fission or fusion, where atoms scatter neutrons or protons or acquire neutrons or protons. In fact, in my previous video, I explained that atoms like barium, iodine, cesium, and krypton can be formed during uranium fission. Yet, Newton conducted countless experiments for years to find the Philosopher's Stone, and as a result, he was exposed to a large amount of toxic substances like mercury and lead. In short, as you can see, it's truly astonishing that one of the founders of science engaged in so much nonsense. This is precisely why economist John Maynard Keynes described Newton as not the first of the Age of Reason, but the last of the magicians. Newton's success in alchemy was a resounding zero compared to his achievements in physics and mathematics, and this led to Newton's declining mental health. If astronomer Edmund Halley hadn't visited him in 1684, Newton would have truly lost his mind and disappeared. Halley came to ask why the planet's orbits were ellipses rather than circles. Many mathematicians at the time pondered this, but no one could find an answer. Halley believed Newton could solve the problem. Fortunately, Newton chose to abandon his fallacies, heed the call of science, and return to his work on gravity. Another concern was the threat that someone else might discover the dynamics of the law of gravitation, which he had discovered years earlier, before him. Newton's recovery stemmed partly from these concerns and partly from a mathematical paper published that same year. Calculus, Newton's greatest invention up to that time, had been independently developed by the great German theorist Gottfried Leibniz. However, unlike Newton, Leibniz chose to announce his invention to the world in 1684. Newton, however, did not publish his work for the reasons I've previously explained. Newton waited until 1693 to publish his work on calculus. This is why Leibniz's notation, rather than Newton's, spread across the European continent. In fact, as you know, we can express derivatives in any way we like. This is Leibniz's notation. This is Newton's notation. As a result, both defined the same mathematics using different symbols, but the rivalry between the two was never-ending. Just like Newton, who had tried to put a high school bully in his place, Newton, now choosing to re-enter the path of victory, wrote his world-famous masterpiece, Mathematical Principles of Natural Philosophy, or Philosophiae Naturalis Principia Mathematica in Latin, or Principia for short, after 20 years of effort. At the age of 44 in 1687, science was so early that its name wasn't even science. It was simply known as natural philosophy. The Principia laid out the mathematics of this philosophy, calculus, and by proclaiming Newton's famous three laws, it succeeded in explaining gravity. Thus, the branch of physics we know as classical mechanics was officially born, and a revolution in physics began. This book is why you know Isaac Newton. Newton's conflict with Leibniz wasn't his only one. Remember Robert Hooke, whose criticism of optics triggered Newton's spiritual collapse? Hooke, known as England's Da Vinci, began writing letters to Newton in 1679, and the correspondence between the two continued for years. Hooke claimed to have discovered gravity a few years before Newton. Therefore, he deserved a reference in the Principia. You can't imagine how enraged this must have been for a man as cantankerous as Newton. Robert Hooke, who observed cells with a microscope and coined the term we now call the biological cell, defined laws such as the law of elasticity that form the basis of engineering and worked in fields ranging from surveying to optics, was making the biggest mistake of his life. Newton was already determined to erase Robert Hooke, whom he disliked, from the annals of history. The only portrait of poor Hooke that might have survived hung in the Royal Society. Newton had that portrait destroyed, and it was solely because of this ambition that we don't know what Robert Hooke looked like today. That's how cantankerous Newton was, but such bitter arguments strengthened him, and he became increasingly famous. His popularity among the public grew so much that he even decided to enter politics. His greatest and most famous political battle was against King James II, who wanted to re-establish Cambridge University as a religious institution, and he won. But Newton's struggle wasn't motivated by his atheism. It was simply a difference of opinion between him and the king. Thanks to his victory over the king, he was elected a member of Parliament and served 2 brief terms in politics. Although it wouldn't be accurate to call him a politician, records indicate that he only spoke in Parliament once, and that was in favor of closing a window. At the time, English coins were easily counterfeited, and the country was in financial ruin. By some estimates, 1 in 10 coins in circulation was a counterfeit. This was where his interest in alchemy would prove useful. The government appointed him first to the mint in 1696 and then to the currency administration. Newton significantly improved the situation by fixing the coin's properties, such as weight, and minimizing inaccuracies in coin production. He also pursued counterfeiters, ensuring their brutal punishment and even their hanging in the public squares. In essence, Newton had found a legal avenue to vent his hatred of those who challenged him and his talents, and thanks to these achievements, he would remain master of the mint for the rest of his life. His political visibility, combined with his academic achievements, opened the doors of the Royal Society wide open. He was appointed president of the society in 1733. He was now deeply obsessed with power and fame. He took countless risks and was incredibly wealthy. Just as he erased Hooke from history, he used his friendship with Halley to steal the star catalogue of Halley's teacher, astronomer John Flamsteed, and publish it without permission. Flamsteed refused to publish his data because he hadn't yet verified it. Newton, however, ignored his views and published the books. Flamsteed then seized 300 of the 400 printed books and burned them. "If anyone has any sense," he said of Newton, "he will realize I've done him and Dr. Halley a great favor." Finally, as I mentioned, Newton lived a wealthy and prosperous life. But in 1777, Newton made a mistake that would be a lesson even to today's investors. At that time, England, seeking to escape its debts, had made an agreement with France to establish a shipping monopoly in the South Seas of Central and South America. Shares in this company were offered to those to whom the government owed money because the monopoly would generate substantial revenues, and this was presented to creditors as a good deal. Newton was among those who purchased shares in this company. The monopoly was called the South Sea Company, and indeed, its stock quickly rose tenfold. Newton wisely sold his shares when the share price had increased, making a profit of $1.5 million in today's currency. But this is where he made his real mistake. After he sold, the price continued to rise, and Newton, overcome by the fear of being left behind, known as FOMO, bought even more when the stock was at a record high. This was one of the first economic bubbles in history, known in financial history as the South Sea Bubble, and it practically burst in Newton's hands. When the bubble burst, Newton lost approximately $4.5 million. After this loss, Newton is said to have said, "I, who can calculate the motion of celestial bodies, cannot foresee human folly." Despite this, he left behind a fortune of $1.5 million upon his death. Despite all this unconventional and unusual life, he passed away on March 22, 1722, at the age of 84. A genius who had made great contributions to science. He never unlocked the secrets of alchemy, but his fears were not realized, and he was not forgotten. After his death, he was considered a hero, paved over the cobblestones of science, and his name will likely remain unforgotten for centuries to come. Or to conclude with the famous lines of the great poet Alexander Pope, "Nature and its laws lay in the darkness of night. God said, 'Let there be Newton,' and all was filled with light.